2, 4, complex numbers. This is not new to you. You've covered this in Algebra 2. I know you need a refresher. That's totally fine, but not new to you. Complex numbers, imaginary numbers, right? So in Algebra 1, they told you can't take the square root of a negative. Eventually, that's not true, right? We do take the square root of a negative. So the square root of -1 we call I, right? So I squared, if I were to square this, I'd get -1, right? So you did that before. It's been a little bit, but you've done it before. So I'm going to come back and write a few extra things here just to help you, but as long as you know this, you can do just about everything today. Okay? So a complex number, a plus bi, where a and b are real numbers, so like 2 plus 4i, okay? Conjugate, we've already done conjugate with rationalizing the denominator when we had like 1 plus the square root of 2. We multiplied by 1 minus the square root of 2, right? That way the square roots disappeared. So same concept here. Conjugate is used to clear complex numbers from the denominator of fractions. So if I say a plus bi, 2 plus 4i, you're going to say 2 minus 4i, a minus bi. And that's going to make the square root of -1s go away, just like we did with the square root of 7 or whatever, okay? Let's add this at the top. If you have I to the even power, okay, if I have I to the even power, let's think about it for just a moment. I squared, right, ended up giving me what? What was I squared? -1. So let's say I had I to the 4th, right? That would be I squared times I squared. So it's -1 times -1, +1. Let's say I had I to the 6th. That would be I to the 4 times I squared. Do you see what I'm saying? All my I to the evens are either a +1 or a -1. If it's to the even, all the i's pair up and there's no more i's left. It's either 1 or -1, okay? If I do I to an odd, what are my two choices? Plus or minus I, right? If I have I to any even number exponent, it's either 1 or a -1, depends on the question. If I have I to an odd exponent, it's either I or -I. Do you guys see what I'm saying? It's kind of nice to know that. You don't have to know that. You don't have to memorize it at all. Oh, hold on one second. You don't have to memorize that, but I think it's kind of helpful if you do. Uh-huh. Are you sure? Okay, and as we do them, you guys will see that that is true. Okay? Write the expression in the form a plus bi where a and b are real numbers. So when they say that, they're saying, give me 2 plus 4i, don't give me 4i plus 2. Even though obviously that's the same answer, that's not how we write it. Okay? So these parentheses, are they necessary? Are they even doing anything? No, so I'm just going to write that down again, 5 minus 2i. These parentheses, is there anything I need to do to make them disappear? No, that's a positive 1 if you want to think about it, so I really don't need them either. The reason they have them there was to let you know this is a quantity and this is a quantity, but neither parentheses were necessary. Do you guys understand what I'm saying? So I get rid of the parentheses first thing because I don't want to accidentally multiply or whatever common mistakes I've ever seen before. I'm just going to add those two together. So what is 5 plus a -3? That's kind of weird, right? I probably would have just written a -3, but what's 5 minus 3? 2. And what's -2i and +6i, like terms? Plus 4i. Is that in the form that they asked us where it's a plus bi? Yeah, so 2 plus 4i. Done. You combine like terms. You combine the real numbers, you combine the imaginary numbers, and you call it a day, okay? You cannot combine a 2 and a 4i. Why? Just like I can't combine a 2 and a 2 squared of 7. They're not like terms. Yeah, it doesn't have an I with it. You can't combine those, okay? This one, number 3, these parentheses are not necessary. Does everybody understand what I'm saying there? There's nothing making them stay. These parentheses are. So what am I going to do to get rid of them? Distribute that negative. So 2 negatives make a positive. 2 negatives make a positive. Does everybody understand that? And now it's just like number 1, right? We're going to combine like terms. So my real numbers, the 7 and the 11, make 18. And the -6i and the +3i minus 3i. Is that in the form a plus bi? Yes. Yeah. And when I say plus, that's just how they say it every time. So it's fine to have minus. I'm just saying the real number first and the imaginary number second. Super easy, everybody? Okay. Excellent. Number 7, what does this problem want us to do? FOIL, multiply the binomials, first, outer, inner, last. We're going to do that quickly because you guys are good at that by now, right? So 1 times 2 is 2 first. Outer, 1 times positive 5i is positive 5i. Inner, negative 3i times 2 is negative 6i. Last, negative 3i times 5i is negative 15i squared. Very good. And pause there. Everybody should be pretty comfortable with that, right? I can't think of a time this doesn't happen in here at least. Those two middle numbers are going to be like terms typically, right? So we're going to go ahead and combine them. So I have 2 minus, that's not a 6 again, 2 minus I. What was I squared? Negative 1, right? Back up the top. 2 negatives make a positive. So what's my final, I'm done, I understand everything answer? 17 minus I. Your final answer to anything can never have anything higher than an I to the first power. If it's higher than I to the first, we have to break it down. The I squared is negative 1, I cubed is negative I, or whatever. So nothing higher than I to the first, or you're not done. Is that okay? Did I lose anybody there? Okay. On this question, I to the 43, first of all, if you can memorize it, great. It's to an odd, so it's either going to be I or negative I. You don't have to memorize that to get it right. I just think it's kind of nice to know which answer I should end up getting. So I to the 43, here's what I typically do. You have to know I to the second is negative 1. That's not an option. You have to know that. You don't have to know higher than that, but let's do this off to the side really quickly. I squared is negative 1. We already said that. I cubed, I can show you how to get it, but I'm going to write it down in just a moment. I cubed is the same as I squared times I. Does that make sense to you? I'll probably just write it down because that's a lot. Do you guys get these are the exact same thing? Okay. What was I squared again? Negative 1 times I is negative I. Same thing. And then I to the fourth is the same as, I'm going to say I squared times I squared. And what was I squared again? Negative 1 times negative 1 is positive 1. So for me personally, I don't think it's too tricky to memorize the first 4. And not that you can't come up with that pattern again, but I think it's nice to know I squared, I cubed, and I to the 4. Again, you don't have to. As long as you know I squared, you can figure out anything you want. I just think it's faster. The reason I like to know up to I to the 4 is because I to the 4 is 1. In my opinion, that's a lot easier to work with than negative 1. Do you see what I'm saying? When you're working with a negative, a lot of times people mess that up. They don't put parentheses in the right place, and they screw up the answer. Most people get 1 right. Do you see what I'm saying? So I prefer to work with I to the 4 instead of I to the second. Okay? So if you don't want to memorize 4 of them, at least memorize this one and that one. I think it's worth your time to memorize those two. Okay? So when we do this I to the 43, if I can make it divisible by 4, I like to do that. So let's see if, obviously 43 and 4 don't work, but take 43 divided by 4 and see how many times that happens perfectly. How many times does 4 go into 43 evenly? 10, right? So this is the same as I to the 10 to the 4th times I cubed. Let me show you what I just did, okay? Oh, I shouldn't have said it that way. I switched it around. That's not wrong. It's just weird. I meant to do it this way. Sorry. Wasn't wrong, just weird. I like to work with I to the 4th because I think 1 is the easiest thing to work with. Do you guys understand what I'm saying? So let's look at this math, and I want to show you that it's the same. A power to a power, 4 times 10 is 40, plus, because multiplication is add, right? The 3. Do you guys see that this is I to the 43 as well? Okay. What was I to the 4 we already said? 1 to the 10 times I cubed. Do you see how easy 1 to the 10 is? Do you see what I'm saying? So that's just 1, so I don't even care. Okay. But now I've got just the I cubed to worry about. Remember, you can't have anything higher than I to the 1. So you can either memorize what I cubed is, or you have to know I squared. It's not an option. So I'm going to pretend you haven't memorized that yet, okay? So that's I squared times I. Do you see that? That's the same as that. What was I squared again? Negative 1 times I is negative I. The final answer to I to the 43 is negative I. This is not the only way to do it. Okay? And remember we said it was an odd, so we knew it was going to be positive or negative I anyway, right? I could show you this way instead. We could say I squared to the something. How many times does 2 go into 43 evenly? 21 times, right? Because that makes how many? What's 2 times 21? 42. How many more do I need? 1. Should make 43, right? Do you guys see that this is the same question? So I could do it this way, but I squared is negative 1 to the 21 times I. And the negative 1 to the 21, I feel like people kind of mess that up. But that's okay. What's negative 1 to an odd power? A negative to an odd is always a negative again, right? So this is negative 1 times I, negative I. Either way, you're going to get the same answer no matter how you do it, or you should. I just think positive 1 is easier than negative 1, personally. Do you guys see what I'm saying? Okay. And we'll practice with that more in a bit if you need it. Let me see what I want to do next. I think that's fine. Yeah, we'll go ahead and do that. We'll do 19 next. That's fine. You cannot have a root in the denominator. Technically, I is the square root of negative 1. You cannot have that, right? So we multiply by the conjugate. This is called the complex conjugate because these are complex numbers, okay? So I'm going to multiply by what on the top and the bottom? To what? What? Oh, yeah, minus, right? 2 minus 4i. If you multiply by 2 plus 4i, you're going to have a whole bunch of i's still. If you multiply by 2 minus 4i, the ones that need to cancel will cancel, okay? So this is just a FOIL distributive property question, okay? So let's do the denominator first because in my opinion, if you do the denominator wrong, you don't want to do the numerator as well. That's a waste of time, right? So we're going to FOIL. What's 2 times 2? 4. I know I don't have to do the outer or the inner because I know I picked the correct conjugate. So I know that this negative 8i and this positive 8i are going to cancel out. I don't even do them. If you're not confident you picked it correctly, you probably should do them and make sure they canceled out, okay? So then it's going to be a minus what? 16i squared. I know it seems like there's still an I in the denominator, but there's really not. What's I squared again? Negative 1. 2 negatives make a positive. So we actually have 20. There's no I. Do you guys see what I'm saying? Okay. So now I'm like, okay, I probably did that right. Let me go ahead and finish with the numerator. Is that okay? So what is 3 times the 2? 6. 3 times the negative 4i. Negative 12i. So I can't actually combine those, so I'm just going to jump down here. Is everybody okay with where I am right now? 6 minus 12i over 20. Pizza. What are all those divisible by? 2, so I end up with 10, right? 3 minus 6i over 10. This answer is fine the way it is. What? Yeah, pizza. Draw your pizza. I should probably be more, I don't know, mathematical, but I know that that works. So with this, you can keep it this way. Typically, your book would probably pull it apart and say 3 over 10 minus 6 over 10i, and then they would maybe probably reduce that. Technically, this answer is fine, but I just want you to know if you check it in the back of the book or if it's a multiple choice option, they may have said 3 over 10 minus what? 3 over 5i. They typically pull it apart, but you don't have to for me. I would be fine with this answer, not that one, right? We have to reduce for sure, but this answer's fine or this answer's fine. Pick one, I don't care. Everybody okay? Okay. This one's not okay. Why is it not okay? Because there's an I in the denominator. So this time, what are we going to multiply by? Positive 5i. Very good. What we do on the bottom, we have to do on the top. Excellent. So if that's hard for you to understand because it's not a binomial, it's supposed to be an easier question, but for some people that's harder. So you could think of it as 0 minus 5i if you wanted, and then we'd multiply by 0 plus 5i, right? But I'm not going to do that, but you can if you want to. So multiply by 5i over 5i. Is that okay? Whenever I rationalize the denominator, I always do the denominator first because I want to make sure the I actually did go away, because if not, I did something wrong and I don't want to do the other half of the problem. It's a waste of my time. Okay, so in the denominator, we get what? Negative 25i squared. So the I didn't go away yet, but what is I squared? Negative 1. 2 negatives make a positive. So did the I eliminate in the denominator? Yes. So now we're going to do the numerator. you know, it's college algebra by now. You should be okay with this in the back. But if you're not, then rearrange it, right? If you're better that way, then do that. Pick one, okay? I'm not going to. I'm going to keep it where it is. So what's 4 times 5i? 20i. And then negative 2i times 5i, negative 10i squared. Watch your signs, right? What was I squared again? Negative 1, 2 negatives make a positive 10. So I have 10 plus 20i because we want the I in the back. What are all those divisible by? 5. So we end up with 2 plus what? 4i over 5. This answer's fine. The i's in the back. You also could have said 2/5 plus 4/5 I. Same thing. Those are all the same. Did I lose anybody on the front page? Okay. Anybody still need this page? All right, backside. I would go ahead and simplify this before foiling personally. Let's pretend the negative wasn't there. What's the square root of 4? 2. So what's the square root of negative 4? No? No? Square root of 4 is 2. Square root of negative 1 is I. Square root of negative 4 is 2i. This comes out as an I. This comes out as a 2. 2i. Anytime there's a negative under the square root, you just pull out an I, and then the negative's not there anymore. Is that okay? All right. So this is really 2 minus, that's still there, 2i. And this is really 3 minus, what's the square root of 16? 4. What's the square root of negative 1? So 4i. I think that looks more manageable personally. Did I lose anybody there? If there's a negative under the square root, just pull out the I and do it like normal, okay? So you guys are going to FOIL this. You're going to beat me, okay? I'm going to FOIL just for the sake of the video, but you guys should be able to FOIL without me helping you too much, okay? So I'm going to say it out loud, but you obviously don't have to listen to me. Beat me there, okay? 2 times 3 is 6. First times first. Outer would be negative 8i. Inner would be negative 6i. Last would be positive 8i squared. You guys should get that without me. And then we're going to combine like terms in the middle. So it's going to be 6 minus 14i. I squared is negative 1. So this becomes a negative 8. Right? And then 6 minus 8 is negative 2. We still have the minus 14i. You always put the I in the end. That's all we can do. Did I lose anybody? Anybody confused at all? Okay, great. On 31, what would we do first? Yeah, let's pull out the i's and let's make those prettier, right? So that's still a 4 plus sign. What is the square root of 81? 9 with that I, right? And it's going to be 7 minus 8i. If you do that first, it's a lot easier. So what am I going to have to do? Multiply by the conjugate, complex conjugate. So what am I going to multiply by on the numerator and denominator? 7 plus 8i, 7 plus 8i. Very good. I'm going to do the denominator first. Okay, you don't have to. Obviously, it doesn't matter, but that's how I do it. So when I do the denominator, if I'm confident that I picked the correct complex conjugate, which I am, right, all I have to check is the first and the last. I don't have to check the outer and the inner. If you want to, you can, but if they don't end up canceling each other out, you did something wrong. Okay, so what is 7 times 7? 49. And then that's minus 8 times 8, which is minus 64i squared. So that's 49 plus 64. Do you guys get that by now? Because I squared is a negative, so it changes your sign, right? And then what is 49 plus 64? Use calculator. Or your brain. 113, okay? So did I get rid of the I or the root in the denominator? Yes. So now I feel confident that I probably did it okay. I'm going to go ahead and do the numerator. All right, so we're going to FOIL again. There's no trick to this one, right? We're going to FOIL. So 4 times 7, 28. Outer is plus 32i. Inner plus 63i. last 9i times 8i, 72 plus 72i squared. Sorry, that's kind of hard to see. So I have 28 plus 32i plus 63i plus 72i squared. Does everybody see that? We're going to combine like terms in the middle. So I still have my 28. I'm going to write it right under here. What's 32i and 63i? 95i. That's going to be minus 72. Is that right? I can't see that. Sorry. What was plus, but the I squared, right? So minus 72. So now I'm going to take the 28 minus the 72, and what do I get there? 28 minus 72. Negative 44 plus 95i. Those all three are not divisible by anything, so I just kept it that way. Again, your book may pull it apart and say negative 44 over 113 plus 95 over 113i, but this is the same thing. I'm fine with that. Is anybody confused at all? Okay, as long as you're slow and careful, right, you're fine. Just be careful that you don't have anything higher than I to the first. Okay, number 41, find the solutions of the equation. Here's why I exist, because on this question, I'm going to try to factor it. What multiplies to 13 but adds to 4? Nothing. It's prime, so it's not helpful. If they had said factor, you would say prime, not factorable. Fine, but they didn't. They said solve it. There's answers to this problem. I just can't find them by factoring. So what am I going to have to do? What do you do when you can't solve it by factoring? Quadratic, right? Quadratic works every time, doesn't it? So somebody tell me the quadratic formula. Very good. X equals negative b plus or minus square root b squared minus 4ac all over 2a, which you are going to have memorized, right? Okay? If you need help, come and see me and I'll wrap it to you. Not on video. Okay? All right, so that's what we're going to do. If you still need to write it down for yourself, you can. What's A? Don't tell me X. That doesn't even make sense. What's A? 1. What's B? 4. What's C? 13. Very good. Substitute. This isn't hard. You literally do what it says to do, right? So X equals is part of the answer. Don't forget that, okay? Negative B is going to be negative 4 plus or minus square root. B squared is 4 squared minus 4AC all over 2A. Take your time and copy that down. Make sure if you have a question you ask me, okay? And then from there, you just do what it says to do, right? You can use your calculator if you want. I find sometimes people use their calculator too much and they get something this easy wrong because they put things in weird. I try not to use it if possible, okay? So I'm going to say negative 4 plus or minus still. Order of operations says you do grouping symbols first, so the square root sign is technically a grouping symbol. So what's 4 squared? 16. There's one minus sign, so I need one minus sign. What's 4 times 1 times 13, which is really obviously 4 times 13? 52. Good. And you finish your grouping symbol, right? You can't take the square root till there's one number underneath there. There's too many things, right? So what's 16 minus 52? So I still have the negative 4 plus or minus. Underneath the square root sign is negative 36, and it's all over 2. I'm going to pause there. What's the square root of 36? 6. So what's the square root of negative 36? 6i, right? So negative 4 plus or minus 6i all over 2. Pizza, what are these all divisible by? 2. So negative 2 plus or minus 3i over 1, so I don't care. Those are my two answers. They're imaginary, so this was the only way, well, I guess you could have tried to complete the square, but this is the only way that you could have solved it. You couldn't have factored is what I was trying to say. Do you guys follow that? How many answers did I get? 2. What was the degree of the question or the equation? What was the degree? Sorry. 2. Right? All right, 47. Find the solutions. Do you have equals 0? Did I add that in there? Oh, perfect. Okay, good. It should be equal to 0. What do we do? What do you try to do first every single time because it's the quickest and easiest? What do we try to do first? Yeah. No, that's a common question. Here's what you can't do. Let me get that equals 0 again. You can't subtract 125 and cube root both sides like we could with a square root. Here's why. When you do that, how many answers should we get to this question? What's the degree? 3. We wouldn't get 3. So what we have to do is get it down to x squared or lower before we can do something like that. So it's obviously x cubed. So when it's x cubed or higher, you have to factor first. That's your only option. Okay? We can't quadratic because it's not x squared. I can't move the 125 over because that won't give me 3 answers. Okay? So we have to factor it. This is only 2 things, so it follows probably a special pattern. What is this probably? A sum of cubes. Very good. It's not going to go away. So we have to learn that pattern. It's a sum of cubes, okay? Where this is going to end up being a binomial, 2 pieces, and this is going to be a trinomial, 3 pieces, okay? So here's the shortcut. Cubed root, cubed root. What's the cubed root of x cubed? X, follow your sign. Plus, what's the cubed root of 125? You can use calculator if you need to. Take the cubed root of 125 if you don't remember. It should be 5. Actually do that if you need help, because I know some of you guys don't use that button on your calculator very often, so if you need help remembering where that is, let me know. If you have a graphing calculator, it's under the math option. If you have a scientific calculator, most of you push the 3 first, and then the second x root of y button, and then the 125, and you should get 5. Is that okay? All right. What do I do? Square the front, square the back, right? So x squared goes in front, 25 goes in the back, always a plus sign, times each other, opposite. We have to start knowing that, okay? Say it again. Square the front goes in front, squares the back goes in back, always a plus sign because anything squared is always positive, right? Opposite sign. If that was a plus, I need a minus. Is that okay? Whenever you have 2 things being multiplied set equal to 0, you pull them apart and set them equal to 0 separately. When you have a sum or difference of cubes, this is never going to factor. You can try if you want to. Don't waste your time. This is never going to factor, so it's not an option, okay? So I'm going to say x plus 5 equals 0, and x squared minus 5x plus 25 equals 0. Well, this is easy. What's x here? Negative 5. There's one answer, okay? I need how many more? 2 more. How many more is this one going to give me? 2 more, right? I just told you it doesn't factor. What's your only option? Quadratic, right? So what's A? 1, B, negative 5, C, 25. Everybody okay? So I'm going to plug it into my quadratic formula. Negative B is going to be positive 5 plus or minus square root negative 5 squared minus 4 times 1 times 25. That's 4AC all over 2A. Pause there. Actually understand how I did it. If you need to go back and look at your formula again, I erased it obviously, but if you need to do that, you can. And here's where you have to be so careful. So I don't use my calculator too much. So I have 5 plus or minus square root. If you don't put this into your calculator correctly with negative with parentheses around it, it's going to give you a wrong answer. What's negative 5 squared? 25. If you don't put parentheses around it in your calculator, it's going to tell you negative 25 because it thinks you mean something else. So be super careful. So it's positive 25, okay? And then what sign does all this get? A negative or a positive? Just one negative sign, so negative, right? What's 4 times 25? 100 all over 2. You simplify that square root as much as possible before taking the square root. So what's 25 minus 100? So 5 plus or minus square root negative 75 all over 2. Everybody with me there? 75 is obviously not a perfect square. I know I need to pull out the I, duh, we'll do that in a second. But 75 has a perfect square in it. We've got 4, 9, 16, 25, 36, 49. What perfect square, what's the highest perfect square that goes into 75 evenly? 25 and 3, right? What's the square root of 25? 5. So I have 5 plus or minus 5. I already pulled that I out. square root of 3 all over 2. If I were to draw my pizza around the 5, the 5i, and the 2, does that help me at all? Nope, so what I had was actually right. 5 plus or minus 5i square root of 3 all over 2 is how you should have kept it. So my three answers are -5, and then these two, because plus is one answer and minus is the other answer. So there's three answers. Did I lose anybody anywhere? Are you sure? Excellent.